Hey guys, welcome to our virtual class today. So yesterday we talked about arithmetic sequence, right? So that was when we had a sequence of numbers in which we were adding the same number each time, right? So 4, 6, 8, 10. In this case, our common difference is going to be 2, and our explicit formula, so A1 here, is going to be 4. So our explicit formula would be a to the n power is equal to 4 plus n minus 1 times d. Alright? That's our arithmetic sequence. Today we're going to talk about geometric sequence. The geometric sequence is where we are multiplying. We are multiplying the numbers by the exact same number each time. So geometric sequence would be like if I did 2, 4, 8, 16. So in here, some of the key things are our A1 is going to equal 2. And then we have this variable called R, and that's going to equal 2 as well. R is our common ratio, is what it's called. And all this is, I'm just going to type this part out. This is just a fancy way to say, what are we multiplying by? Now, if usually, you're going to have like 2. We're multiplying by 2, or if our common ratio is 2, that means we're multiplying each time by 2. If our common ratio was 1/2, right, this is the same thing as saying that we are dividing by 2, right? All right, so if it looks like we are dividing by 2 or dividing by 3 each time, our common ratio is going to be 1/2. So, when it comes to geometric sequence, we actually have the same 2 types of equations as we had before. All right, so we have a recursive formula, and we have the explicit. So with the recursive formula, it's going to be that the value at whatever term is equal to the value at the term immediately before it times the common ratio. And again, this equation is not useless unless we're literally just given we're given the previous term. It's not all that useful. Because, again, let's look at the 50th term. If I wanted to find the 50th term, then I have to know what the value of the 49th term is in order to get the 50th. Well, what if I don't know the 49th? In that case, I had to have the 48th term in order to get the 49th term in order to get the 50th. Well, what if I don't have the 48th? Well, then I had to have the 47th term to get the 48th term to get the 49th term to get the 50th term. So you see how it just is a very bad cycle of terms in order to get to the recursive. So a recursive formula is going to be this, and you'll usually see it with a semicolon, and then it's going to have A1 is equal to, and then whatever your first term is. So this is how the recursive form looks, okay? Now how about the explicit form? So the explicit form is going to be that the value at a certain term is going to be equal to A1, the very first term we have, times our common ratio to the n minus 1 power. Alright, so remember, we need to take this to the power of n minus 1. This is the biggest reason, the biggest difference between this and the arithmetic is just the explicit formula. Now, let's say I had a sequence of numbers. Actually, the notes here. Alright, so I do not have here. And we can go over the actual questions that are in your notes on Monday if you'd like. But let's say I had a sequence that was 4, 16, 64, 256. So my first term, A1, is going to be equal to 4. Right? It's right there. My R, my common ratio, is going to be equal to 4 as well. I don't know. I guess I just keep choosing the exact same. So what would my recursive and my explicit formula look like? So take a look at the recursive first. My recursive formula is going to be a to the n power, or a to the n term, because we don't know what n is. I haven't told you what that is yet. So the a to the n term is going to be equal to a to the n minus 1 term. Again, I don't know what n is yet, so we can't actually put anything else there. Times 4. And then you would see a semicolon. A1 is equal to 4. Alright. Now let's talk about the explicit formula. In this case, I'm going to take the value of a to the n power is equal to 4, because that's my A1, the first term, times 4 to the n minus 1 power. Alright. Now let's say I wanted to I'll give you guys a different set of numbers. Let's have 2, 6, 18, 54. Okay. So my A1 is going to be 2. My common ratio is going to be 3, right? Because I'm going to do 6 divided by 2 equals 3. So that's how you find, is equal to 3. And that's how you find R, is you take one term divided by the previous term. So R is 3. Now my explicit term, my explicit formula, is going to be a to the n is equal to 2 times 3 to the n minus 1. Now what if I wanted to take this, I wanted to use what I have here and turn it into the recursive formula. What am I going to do? Well, first I'm going to realize, okay, I'm going to remember what my recursive formula is. A(n) is equal to a to the n minus 1 times r. And I'm going to see what do I know from here. So I know that 2 is equal to the a to the 1. Yeah, I guess I'll put the semicolon. A1 equals. So 2 is equal to A1. So I'm just going to go ahead and put that one here. A1 is equal to 2. My R, I don't know what term I'm looking for. So these are going to stay the same. AN is equal to A to the n minus 1. And then the only other thing I need is my R value. My R is 3. I'm going to put multiplied by 3 and then put my semicolon. And that's really all there is to this. So in order to figure out if a geometric sequence is a geometric sequence, R is never going to change. All right, from term to term, it never changes. The same number each time. So how do we find R? R is going to be, you can do it a few ways. So R is equal to A2 over A1. And if you want to compare it, then you could do like A2 over A1 is equal to A3 is over A2. All right, so by setting up that kind of ratio, it's their proportions, their ratios. By setting that up, you could determine if a sequence of numbers is a geometric sequence or not. All right, so that's all I have for you on this material. Your homework for tonight is it's going to be page 279, 9 to 45 odd, I think is what you said. It literally it looks like it says m to the third, but I think it's odd. Now, there is a formula sheet that I'm going to give you guys on Monday, and hopefully it'll make a lot of this clear, and you could use it for your, for your tests and everything like that. But, and if I could find it, I might have left it at school. If I did, I'll upload it tomorrow for you guys. Maybe it'll help you out with your homework. Otherwise, I'll make sure I have it for you guys on Monday. If you have any questions, feel free to send me an email. Like I said, I'll be online during our class period. On Friday, tomorrow. Or today, I guess now, because it's almost 1 o'clock. But anyways, I hope you guys have a great weekend, and if you enjoy, your semi-day off and everything. And I'll see you guys on Monday, and we're going to pick it back up.